What about the knowledge of the precise damages? Well, there's certain huge uncertainties. In the past few years, suddenly a disease which was hardly recognized and hardly known, an emerging virus called the Zika virus, is spreading massively around the world. There are reasons to believe that global warming is increasing the range and the force of transmission of that virus. And there are many other emerging or re-emerging vector-borne diseases, for instance, diseases carried by mosquitoes. The range of malaria transmission, which is temperature dependent, is expanding as more and more regions reach the thresholds at which the air is warm enough for the malaria to be transmitted from individual to individual, roughly 18 degrees Celsius threshold of temperatures. So global warming is spreading the transmission zone of malaria, but by how much and how fast? There's uncertainty. Just it's not known. What will be the effects on major crops of this warming? We know, for example, that Arabica coffee, which I drink a lot of, is highly sensitive to temperature. Places in Brazil, for example, that grow Arabica coffee are not going to be able to produce in the future. How fast is that going to happen? What kind of countermeasures can be taken? There are big uncertainties. We know that we're not the only species affected by global warming. We know, in fact, that whole ecosystems will be affected rather deeply because in an ecosystem, when some species die out or disappear from the food chain, that has a cascading effect, a multiplier effect on the whole ecosystem. How is that going to work out in different parts of the world? Big uncertainty because the ecologists simply don't have enough detailed knowledge of each of these ecosystems to be able to make highly certain predictions of what will happen. And we certainly have a lot of uncertainty on technology, performance, the specifications of batteries in the future, the specifications of biofuels, the economics of carbon capture and sequestration, the performance of storage sites underground where you might pump CO2. Will it stay underground? What will be the cost of storage? How many parts of the world have good storage sites? What will happen to declining prices for renewable energy? There are lots of uncertainties in all of this. We need, therefore, to operate in a range of uncertainty. And this is really the important point. Now, some people say that uncertainty means, oh, don't do anything, we're not sure. But that's not how we live our lives at all. I pay a fire insurance or housing insurance, not because I know that something's going to happen, but precisely because I know that there are big uncertainties that I want to insure against. I pay liability insurance as anybody that drives a car pays because you don't know whether an accident is going to occur and whether you're going to be liable for some losses and damages. And so we handle uncertainty by recognizing it, by quantifying it, and by insuring against it, and by taking precautions. The argument that because there are uncertainties about climate change, we shouldn't do anything right now makes no sense in an insurance context. Indeed, we've got the biggest risk of all, that if things turn out as some of the more pessimistic range of uncertainty predicts, we could destroy the ability to grow food for hundreds of millions of people. We could make life uninhabitable for places where hundreds of millions of people, even billions of people, live right now. Do we therefore say that because of uncertainty we do nothing? Or do we use the basic logic of insurance to say, I don't want to go down that road. I want to insure against the worst. Even if it might not happen, I'm willing to invest. I'm willing to pay a premium, maybe a premium on a little bit more expensive zero carbon energy, to pay a premium on more research and development to speed the improvement of zero carbon technology, to pay money to test carbon capture and sequestration or nuclear energy just in case we need that because other methods won't work. I'm ready to pay that insurance premium. And I think what the lesson of all of this is, when you think of it in the insurance context, we face such tail risks, as they're called. That means extreme disasters from this risk, that by itself is one of the most important reasons why we have to abide by the climate agreement that we have reached in Paris. Even if it were the case, and it's not, that 1.5 degrees C or 2 degrees C warming would be benign. We know it's not. But even if it were the case, we should be so afraid of the feedback effects, the natural effects, the things we don't know that we know are possible because of the warming, to take the insurance on a planetary scale to make sure that we reach these agreements. Sometimes this is phrased as a precautionary principle. Where do you put the burden of proof? The strange idea among some climate skeptics is to put the burden of proof on those who say that this is dangerous. And the skeptics say, until you prove 100% that this is dangerous, I don't want to do anything. But the precautionary principle puts the burden of proof on the other side, which is stop doing things which have a plausible likelihood of being very dangerous and potentially disastrously dangerous. And so the precautionary principle alone should tell us, be careful. The science is known enough, the observed effects are powerful enough, the risks are high enough that we have to be very, very careful. And investing in achieving the Paris Climate Agreement and how to do it in a low emissions development strategy consistent with the Sustainable Development Goals has to be our priority, because the risks of the downside are so grave, so serious, that we have to do everything we can to avoid the dire consequences if we continue on the current path that could happen, not necessarily, but are so worrisome that we have to head them off. So that is the basic logic of acting under uncertainty. We need a kind of insurance mentality. We have to pay a bit of an insurance premium to prevent the worst from happening. We have a lot of reasons to be afraid, but we have a lot of reasons also to have some optimism that we have pathways to safety. And you're going to be hearing about those pathways in the coming modules, about the specific technologies and the specific choices that we can make to get to climate safety.